Hi and welcome. You will learn Mosfet transistor, how Mosfet works. You will learn also the Mosfet structure, types of Mosfet. We're going also to see the Mosfet enhancement mode and the Mosfet depletion mode. We're going to see the Mosfet advantages, limitations, and Mosfet applications. You're going to know and master how to test any Mosfet using the multimeter. We will talk about Mosfet failures and how to troubleshoot it and replace it. See the Mosfet overview. Okay? So, as you see here, we have a lot of types of Mosfet. Okay? So, the Mosfet stand for metal oxide semiconductor field effect transistor. So the MOSFET is exactly like a transistor, okay? But there is a small differences. We will see all this in details. So this is a MOSFET with 8 terminals or pins. As you see, this is the first, the second, the third, the fourth, the pin number 5, pin number 6, pin number 7, and pin number 8. Okay? For this transistor, it has 3 terminals, as you see. We have here the first, the second, and the third. Always for this kind of MOSFETs, the first terminal is the gate, the second is drain, and the third is source. Okay, so we have gate, drain, and source. We will see and discuss all these in details in the next lectures. Okay, this is another type of MOSFET, as you see with the shape. Also, we have here 3 terminals. Okay, this is the MOSFET with 8 terminals, exactly like this one, but the shape is different. Okay, as you see, we have here 4 terminals, and in this side also we have 4 terminals. Okay, also here this is another type of MOSFET with 3 terminals. The same here, another MOSFET with 3 terminals. Okay, this true symbol is the MOSFET symbol, as you see here. So we have here G is for gate, D for drain, and S for source. Okay, so we have here gate, drain, and source. Okay, the same here. This is another symbol, gate, drain, and source. This class is just an overview. We will dive in the explanation in the next lectures. Okay, we're going to see the MOSFET definition and the MOSFET historical. Okay, so let's begin with the definition of the MOSFET. As you see here, the MOSFET or the metal oxide semiconductor field effect transistor MOSFET is a semiconductor device that can be used to conduct electric current or voltage in one hand and insulate it on another hand. Okay? Basically, the MOSFET acts as an amplifier or as a switch. We can see that it is used to control and regulate the flow of current or electronic signals in electronic devices. The MOSFET can be either simple electronic components or an integrated circuit IC designed in a very small size. It is one of the most important components in electronics and science history. Okay? So let's go now to see the Mosfet historical. Theoretically, the Mosfet was designed in 1920 by Julius Edgar for the purpose of controlling current, but the technology necessary for its construction and build was not available before 1950 because of its complexity. With the advent of integrated circuits (ICs), the Mosfet construction has become a reality. It was invented by Mohammad Atala and Dawon Kang at Bell Laboratories in 1959. 4 years after its construction, it appeared in the integrated circuits in 1963. Okay, before 1950, the construction of the MOSFETs was not easy, okay, because the MOSFET is very complex. It is an integrated circuit. But with the advent of ICs or integrated circuits, the MOSFET built become simple. Okay, to see the MOSFET structure. So, as you see here, the MOSFET has three main terminals, as we see before. Okay, it has the gate G, the drain D, the source S. Okay, so as you see here in this picture, this is the MOSFET. Okay, so we have gate, drain, and source. Okay, and note that this terminal is connected to this. Okay, so if you use the multimeter or the voltmeter, and if you check the continuity between this terminal and this, you will find a buzzer or a continuity, because these two terminals, this and this, is connected together. Okay, so the MOSFET is typically like a transistor. It is used in both the analog and digital circuits. Here we have two symbols. This is the symbol of the MOSFET, and this is the symbol of the transistor. As you see here, for the MOSFET we have gate, but for the transistor we have B, means base. Okay, we have here drain, and here we have collector. We have here source, and here we have emitter. The same logic and the same principle, but there is a slight difference between the MOSFET and transistor. Okay, so for the MOSFET, it has two types, PNP and NPN MOSFET. Okay, as you see here, we have here a small arrow. As you see, this is a small arrow that determine for us whether MOSFET is a PNP MOSFET or NPN MOSFET. Okay, so if the arrows, go from source to gate, as you see here, so the direction of this arrow is to gate. So this MOSFET is NPN. And if this arrow is the opposite of the state, means from gate to source, that means the MOSFET is PNP. Okay? For the transistor, there is a slight difference. Okay? So we have also here the small arrow. So for the transistor, it's the opposite of the MOSFET. When this arrow is from base to emitter, means this transistor is NPN. Okay, and if this small arrow is in the other direction, means from emitter to base, the transistor is PNP. Okay, so this is just one way to determine if the transistor and the MOSFET is PNP or NPN, but we can also determine the type of MOSFET or transistor using the multimeter. We'll see all this in the next classes. The MOSFET working principle. How the MOSFET works. So, the working principle of any MOSFET device is based on monitoring and controlling the flow of electric currents between drain D, okay, as you see here, we have drain D and source S and source, okay. So the working principle is based on controlling the flow of electric current between these two terminals, okay, drain and source. As you see here, this arrow means the electric current flow, okay, between drain and source, okay. So it is based on monitoring and controlling the flow of electric current between drain and source terminals by varying the value of intensity current that is applied to the gate. So this flow of electric currents is controlled by the small current that arrives to the gate here, okay. So as you see here, when the voltage arrives here to the gate, the MOSFET goes to open state or to on state, and the current flow from drain to source, okay. The flow of electric current between drain and source is determined by the voltage that arrives to the gate, okay. So when, for example, the voltage that we have here is 0, there isn't no flow over here. And when the voltage is 5 volts or 3 volts, the electric current will flow from drain to source, or the opposite, in accordance with the type of MOSFET, PNP or NPN. Okay? So, the electric current between drain and source terminals happens by varying the value of the current that is applied to the gate. Okay? The MOSFET can be used in many places in electronics. It can be used as an amplifier or as a switch. Okay? So, as a switch, because the voltage or current that is here control the state of the MOSFET. So if the voltage is present, the MOSFET is on. If the voltage is absent, the MOSFET is in off state. So on, off, on, off, on, off. Exactly like a switch. You see, okay, the types of MOSFETs. Okay, so as you see here in these slides, we have MOSFETs can be classified into two types or modes. So we have MOSFET, we have the first mode is depletion mode or depletion type MOSFET. And here we have enhancement modes or enhancement type MOSFET. Okay, so for the depletion type MOSFET or the depletion mode, we have also two types, N-channel MOSFETs and P-channel MOSFETs. Okay, the same for enhancement type MOSFET, there is two types, P-channel MOSFET and N-channel MOSFET. Okay? So we will see what is the enhancement type MOSFET and what is the depletion type MOSFET in the next classes. Okay? To see the enhancement type MOSFET. Okay? So here we have enhancement modes. When there is no current or voltage on the gate terminal of the MOSFET, this is the gate of this MOSFET. Okay, so when there is no current or voltage here, what will be happen? It does not conduct, so no conductivity in the other side. So if there is no current here, there is no conductivity here. Okay? If more voltage applied on the gate terminal, and now the opposite, if there is a voltage here, okay, what will be happen? The device will have a good conductivity. So the gate terminal is the control terminal of the MOSFET. So if we applied a voltage here, this part of the MOSFET will conduct the electric current. Okay, so we will get here a conductivity. Okay, so if the voltage is present, we have here conductivity. If not, we will not get here any conduct or conductivity. Okay, so this is the enhancement type MOSFET. The enhancement MOSFET is classified into two types: N-channel enhancement type MOSFET and P-channel enhancement type MOSFET. Okay? For the depletion type MOSFET, depletion mode, when there is no current or voltage on the gate terminal of the MOSFET, so this time, if we don't have here any current or voltage, what will be happen? It shows the maximum conductivity. So the depletion type mode is the opposite of enhancement type mode. Okay? So for the depletion mode, when there is no current or voltage here, the MOSFET shows a maximum conductivity between these two terminals. Okay, so the electric current will flow from drain to source or from source to drain in accordance with the type of MOSFET. And as the voltage on the gate goes to negative or positive, the conductivity will decrease gradually. Okay, so if the voltage here is absent completely, we will get the conductivity here between drain and source. And if the voltage on the gate goes to negative, means decrease or increase the positive, the conductivity will decrease gradually. Okay? So the depletion MOSFET is classified into two types: N-channel depletion type MOSFET and P-channel depletion type MOSFET. Okay? I'm going to see what is the MOSFET advantages. So as you see here, MOSFET advantages, benefits and advantages of MOSFET. So the MOSFET has a smaller sensitivity. The first advantage, lower cost. Okay, small size. As you see, this is some types of MOSFET, but there is other MOSFETs that has a very small size. This type of MOSFETs is used in the motherboards and in the integrated circuits. Okay, so because there is some integrated circuits exactly like this one. This is a MOSFET, but there is some integrated circuits with exactly this size, but it contains many millions of MOSFETs. Okay, so the advantage number 4 is fast switching. Okay, so the fast switching is one of the advantage of the MOSFET. So when we apply a voltage in the gate of the MOSFET, we will get the electric current flow between drain and source of the MOSFET. So the MOSFET become on in the on state. If there is no voltage on the gate, the MOSFET will be off. So on, off, on, off. This state changement means switching. Okay, so the MOSFET has a fast switching. So it is noiseless when operating. So the next advantage is better efficiency. Of course, it has a better efficiency. Okay, low operating voltage. Yeah, its operating voltage is from 3 to 5. Okay, it can be operated with 3 volts, 5 volts, okay, etc. So the low operating voltage and long life. Okay, long life. The next advantage is it can withstand and support the heat. Yes, it can support the heat. The MOSFET supports the heat. Okay, it has a very high input impedance, which increases efficiency. Okay, so low power consumption. Okay, the same as low power voltage or low power consumption. Okay, the MOSFET is used in developments of integrated circuits. Okay, all integrated circuits contains MOSFETs. Okay, so it can be operated in either enhancement mode or depletion mode, as we see before. Okay, the next advantage is easy to manufacture, and here the MOSFET limitations. So as you see here, the MOSFET can be easily damaged when electrical current is not in its level. Okay, so if the electrical current is not in the MOSFET level, it can be failed and damaged. Okay, that's why we use always with the MOSFET in the motherboards of any electronic devices, fuses and xenon diodes in order to protect it. Okay, so it can be easily damaged when electrical current is not in its level. Okay, so we have here the appearance of some issues due to electromobility. Of course, as any electronic device, sometimes some issues can be appeared, okay, because of the mobility of electrons. Okay, so the MOSFET can be affected by rays and radiation. So this is one of the MOSFET limitations. It can be affected by rays, okay, and radiations. Okay, so the great sensitivity, as you see here, the great sensitivity to static discharge. We should always pay attention to static discharge because the MOSFETs, and not just the MOSFETs, but all electronic components, capacitor, resistance, diodes, all electronic components can be damaged by the static discharge. So you should pay attention when you handle MOSFETs. It is very susceptible to overload voltages. the same principle as the currents, the electric currents. So, of course, the MOSFET has a particular voltage, or its working voltage is a limit. The working voltage of the majority of the MOSFETs is between 0 to 30 volts. Okay? So the next limitation is special handling is required during installation in order to avoid the static discharge and then damage the MOSFET. We're going to see the MOSFET applications. So as you see here, it is used in high frequency power amplifiers. Okay? So as we see before, the MOSFET can be used as an amplifier or as a switch. Okay? So the MOSFET are used to make integrated circuits, ICs. Okay? It is used in digital ICs such as microcontroller, microprocessor, CPUs. CPUs means central processing unit, memories like RAM, for example, random access memory that we find in computer motherboards, laptops, etc. Okay, and also for the ROM, etc. Okay, so it is used in motors to speed up its control. MOSFET is used also in SMPS circuits. Okay, SMPS circuits means switch mode power supply circuits. Okay, the MOSFET also is used in voltage regulator circuits. It is also used on the computers, laptops, tablets, and phones motherboards. The MOSFET is used also in the CMOS logic circuits. The CMOS means complementary metal oxide semiconductor. So the use of the MOSFETs is very wide. Okay? The MOSFET is used in the all electronic devices. I want to see how to check the MOSFET. So let's get started. So here we have checking the PNP MOSFET. As we see before, there is PNP MOSFET and NPN MOSFET. Okay, so checking the P. Here we have it supports high speed operation. Okay, PNP MOSFET. First, we should set the voltmeter. Okay, the voltmeter or the multimeter selected to diode. Okay, then we put the read probe of the voltmeter on the gate D of the MOSFET. Okay, so we should put the read probe here in the gate. As you see, this is the first terminal of this MOSFET. We have here gate. Okay, and then black probe once on the drain and once on the source. So the read probe here and the black probe once here and once here. Note that this terminal is exactly like this one. Okay, we have here continuity between these two. Okay, if we notice that the resistance is low, that means that the type of MOSFET is PNP. Okay, so if we put the read probe of the multimeter in the gate and the black probe once here and once here, and we note that the resistance showed in the voltmeter is low, that means that the type of this MOSFET is PNP, okay? PNP, okay? Note that the direction of the arrows in a PNP MOSFET is towards the gate. And this is another way to determine the type of MOSFET based on its symbol only. So we can know if the MOSFET is PNP or EPN using the voltmeter, and also we can just base it on the arrow that is shown on its symbol to know if it's PNP or EPN. As I told you before, if the arrow is goes from source to gate, that means the MOSFET is NPN, and if the arrow direction is from gate to source, that means the MOSFET is PNP. Okay? So now let's go to 5.2, checking the NPN MOSFET. So the same logic and same principle. Set the voltmeter selector to diode option. Then put the black probe this way. This time we will put the black probe of the voltmeter on the gate and the red probe once on the drain and once on the source. So in this time the opposite of the operation that we did for the PNP MOSFET. So now we will put here the black probe, not the red probe. Okay? To check the NPN MOSFET, we have an NPN negative. So because we have negative NPN, we should put the negative probe in the gate. And for PNP, we have PNP the positive, we should put the red probe in the gate. Okay? So to check the NPN MOSFET, we should put the black probe here in this terminal in the gate, and then put the red probe once here in the drain and once again in the source. And if we notice that the value of the resistance shown by the voltmeter is low, this means that the type of MOSFET is NPN. Okay? Note that the direction of the arrow on an NPN MOSFET is towards the source. Okay? The opposite of the PNP MOSFET. Okay? So this is the MOSFET. To check if this MOSFET is PNP or NPN, we should use the voltmeter or multimeter. So if we place here the black probe in the gate and the red probe once here in the drain and once again here in the source, and we measure with the voltmeter a low resistance, that means this MOSFET is NPN. Okay? Going to see how to test the MOSFET. Okay? So let's get started. There are many ways to test MOSFETs. We will discuss one of the best of these methods, which is very effective. First, connect the negative probe of the voltmeter to the source of the MOSFET. Then touch the gate of the MOSFET with the positive probe of the voltmeter. Okay? So first, we should connect the negative probe of the voltmeter to the source. So we have here source, so we should connect the negative probe of the voltmeter here to the source, and then use the red probe and touch the gate terminal. Just touch it. When we touch the gate with with the red probe, what will be happen? Let's read here. This process we have done will charge the MOSFET by the voltmeter, making it in working state on. So when we put the black probe in the source and the red probe of the voltmeter here in the gate, just we will use it, we will touch the gate with the red probe, the MOSFETs will be charged with electrons and will go to on state. Okay? To on state. So after this operation, you should get a low reading between the source and the drain because the current, the electric current will flow between drain and source because we activate the gate with the voltmeter. Okay? 3. The last operation that we will do to be sure 100% that our MOSFET is serviceable is to touch with one of your fingers between source and gate. Between source and gate. Or drain and gate. Okay? In order to discharge the MOSFET through your finger. After discharge of the MOSFETs with finger, the reading should go high between drain and source, indicating a non-conductive device. Okay? So, if we use after charging these MOSFETs, if we touch between gate and drain with our finger, or between gate and source, the MOSFET will be discharged through our finger. And then, if you use the voltmeter and measure the resistance between drain and source, you will find a high resistance. Okay? Indicating a non-conductive device. So, this is the way, the best method that you can use to verify if the MOSFET is good or no. Okay? Using your multimeter. See MOSFET's failures or damage. So, as you see here, the MOSFET is damaged when there is a short circuit between drain and gate, or source and gate, or even drain and source. Okay? So when you have a short circuit between two of these terminals, gate and drain, gate and source, drain and source, or source and gate, that means this MOSFET is damaged. Okay? But avoid to touch the gate with the read probe of the multimeter. Okay, so using the multimeter, put the selector to the buzzer option or continuity option. Then put the negative probe of the multimeter or voltmeter in the gate. So you have to put the negative probe here and put the red probe once in the source S and once in the drain D. If you hear a buzzer, then the MOSFET is damaged. Okay? You can also check the continuity using the multimeter between source and drain. And if you hear a buzzer, then the MOSFET is failed. You should replace it by a serviceable one. So, to check if the MOSFET is failed or not, you have to put first the black probe here, not the red probe, the black probe of the multimeter in the gate terminal, and then check with the red probe once in D and once in S terminal. If you hear a buzzer or a continuity, that means 100%. the MOSFET is failed, you should replace it with another one with the same part number. Okay, the part number always is figured here. Okay, in the MOSFET. Okay, there is another method to check if the MOSFET is good or not using just your finger. If you touch the MOSFET over here in its body and you feel that is very hot, okay? Its temperature is not normal. That means the MOSFET is damaged, okay? To say an important note for any computer technician or electronic technician, please pay attention to these notes, okay? If you find during your maintenance that a given MOSFET is damaged and you want to replace it, please pay attention. You have to replace the failed MOSFET with another of the same type, okay? Of the same type. If the failed MOSFET is PNP, you have to replace it with another PNP MOSFET. And if it is NPN, you must replace it with NPN MOSFET. Okay? So when you troubleshoot your motherboard or any device that is failed and you find that the cause of failure is a given MOSFET and you want to replace it by a serviceable one, you should pay attention to the type of this MOSFET. If it is failed or damaged, you cannot check it, because if you use the multimeter to check it, you will find a continuity and a buzzer because it is damaged. But you can use its part number to identify if this MOSFET is PNP or NPN. So if you find it PNP, you should and you have to replace it with PNP MOSFET. And if you find it NPN, you must replace it with NPN MOSFET. If you replace a PNP MOSFET with another MOSFET with different type, for example, if you replace a PNP MOSFET with NPN MOSFET, you will damage other circuits in the motherboard. That's why this note is very important. Okay? We're going to see some MOSFETs in the real motherboards. Okay? So this is a laptop motherboard. Okay? Real laptop motherboard. As you see here, we have here a lot of components. We have capacitor, we have injectors or coils. Okay, we have PF capacitors. Okay, we have this is the RAM, and we have here the MOSFET. Okay, this is the MOSFET as you see here. We have this is MOSFET and this is MOSFET. Okay, so this is MOSFET with 8 terminals or pins. Okay, 8 terminals or pins. So for the MOSFET with 8 terminals, it is the same as the MOSFET with 3 terminals. But here, 4 terminals or pins is for drain, and 3 other terminals is for source, and 1 terminal is for gate. Okay? We have here another motherboard where we have a lot of electronic components this is PF capacitor, okay, this is inductor or coil, and this is chemical capacitor, okay, and here we have Mosfet, okay, this is Mosfet with 8 pins, okay, as you see here. So if you focus here, we have here a small sign here, as you see, we have a small sign, a small triangle, means this pin is the pin number 1, 2, 3, pin number 4, number 5, number 6, number 7, and 8. So always the pin number 1, the pin number 2, the pin number 3 is the source. These 3 pins are connected together, okay? This pin is for the gate, okay? The fourth pin of the MOSFET with 8 terminals is for gate, and the other 4 pins or terminals is drain.